All right, so the front side of this is limits to infinity. This is really just your end behaviors, okay? The edges, so horizontal asymptotes, we're looking where it levels off. And I put the rules on here for you, but let's just go over. If your numerator degree is smaller than the denominator, it's automatically 0. If they're equal, you use your leading coefficients. And if the numerator degree is bigger, it's a slant asymptote, which means it's either going to go up or down. And at that point, you're just checking, is it positive or is it negative? Okay. So let's just go through and compare the powers. So, and I usually just circle them. So for number 1, and I also call this like who's in charge here. Who's in charge for the numerator? 4x to the third. Good. Who's in charge for the denominator? 5x to the third. Okay, so they're the same, and your answer is just going to be 4/5. And so people will be like, oh, that's it. Yes, but there are other rules, and this is only for positive and negative infinity. If its limit as x goes to 2, that's the analytic stuff that we were doing before, so yeah, it's not that bad, but it's going to be mixed in with all the other problems. So don't like sleep on this one, okay? For this one, x is in charge of the numerator, x cubed is in charge for the denominator. So that's the numerator being smaller, so that's going to be 0. Good. All right, for this one, we've got 5x cubed in the numerator and negative x squared in the denominator. That's a situation where it either goes up or down. Now, here's where you have to look if it's going to positive or negative infinity. This one's going to positive infinity, so come with me on this. We're going to use our imaginations. Imagine plugging in a really big positive number, okay? If you take a really big positive number and cube it, it is still a really big positive number. And if you multiply it by 5, it is still a really big positive number. So numerator's positive. Down here, if you take a really big positive number and square it, it's a really big positive number, but then you're going to make it negative. And you only need to test the parts you circled. It's just the who's in charge here. Everything else becomes insignificant. It's like I only want to speak to the manager, okay? And so a positive over a negative is a negative, and it would be negative infinity is your answer. So you're just checking the sign. So looking at this one, who's in charge for the numerator? Yeah, x to the 4th, and then denominator x squared. 4 is bigger than 2. So again, it's either going to go up or go down. We're going to test. This one goes to negative infinity. So in your imagination, you have to think of plugging in a really big negative number. So if you take a really big negative number to the 4th, it would be positive because that's even. And the same thing's going to happen with squared. So you have a positive over a positive, so positive infinity. All right, here it's x, but I would put the negative with that. So it's a negative x in the numerator, square root of x in the denominator. Does anyone remember what the exponent is? Like what's the power for a square root? 1/2. So a cube root, just for the sake of going over it, would be 1/3. Okay, so it's a fraction. 1 is bigger than 1/2. So again, it's either going up or going down. Let's test. This one's positive infinity. So you would have a really big positive number, but then you would make it negative. And if you take a really big positive number and square root it, it would be positive. So this one is going to be negative infinity. For this one, there's nothing with the 4. So it's really x to the nothing, if you want to think of it that way, x to the 0. So which situation do we have going on here? Yeah, 0 is smaller than 2. So it's just going to automatically level off at 0. This next one involves a log property. So I always bring this up and everyone just kind of stares at me. We did cover it in pre-calc. Do you remember the log property where you're allowed to take this exponent and write it out front? Sort of vaguely. Okay, so you can scribble out that 3 and put it in front. And so you have 3 ln of x in the numerator and then ln of x in the denominator. So those are the same. So you would use the coefficients, which would be 3/1, which would just be 3. Now for this one, I printed it on the paper, but I didn't bring it up yet because we didn't get to a problem where this happened. An exponential, which would be like e to the x, all right, is going to grow faster than a polynomial. Polynomial means x or x squared or x to the third or x to the fourth, like x to a number. So exponential like beats polynomial, which beats logarithmic. So if you're looking for who's in charge here, that's the order in which they go. Okay, so exponential is going to grow faster than polynomial, is going to grow faster than logarithmic. So when you look down here, we have the 3x squared in the numerator. For the denominator, x is a polynomial, ln of x is a logarithmic function. So the polynomial is the one that's in charge there. Polynomial beats logarithmic. So which situation is that? Looking at the ones that I circled. Yeah, we're going to have to test. It's either going up or going down. If you plug in a really big positive number to both of those, they're both going to be positive. So positive infinity. All right, here we have the 2x and the ln of x. 2x is a polynomial. ln is logarithmic. So it's a situation where the numerator is bigger than the denominator or the numerator is growing faster than the denominator. So again, it's going to either be up or down. If you plug in a really big positive number to both of those, what's going to happen? They'll both be what? Yeah, they're both just going to be positive. So going up, positive infinity. This next one's interesting. Think about your cosine graph. What does the cosine graph look like? It's a wave, and it stays between what two numbers? 1 and -1. So in other words, it's very, very, very small. Okay, so like very small. Just write yourself a note. I know that's like very technical, but very small, between 1 and -1. Very, very close to nothing, actually. And if you're going out to infinity, like imagine the denominator being very, 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 very huge. The biggest number you can possibly think of. You end up with a situation like 1 over a gazillion. Like a situation like this. Do you get what I'm saying? Only like as many zeros as you can possibly imagine. So where is it going to level off? 0. It's going to go to 0. You end up with super, 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 super tiny numbers. So cosine stays between 0 and 1. It's very, very, very tiny. The denominator, though, is going to infinity. So you end up with a gigantic denominator, and so it's going to level off at 0. Now, these last two, what do you notice about them? Because I did a compare and contrast here. Yeah, and well, actually, they're both. One's positive, one's negative. Yeah, one's positive infinity and one's negative infinity, but they're both like the same problem. Okay, so if you're going to positive infinity, the 4x cubed is in charge for the numerator. The e to the x is in charge for the denominator. This is polynomial. This is exponential. You have a situation where the numerator is smaller than the denominator. Exponential grows super, super fast. So where is that going to level off? 0. Exponential grows so quickly, your denominator is astronomical. You get a situation like this, where it's like 1 gazillion. This one is the exact opposite of that. Instead of the exponential being super, super, super important, it's now super, super, super unimportant. The negative flips it. So 4x cubed is in charge for the numerator. The negative 7x cubed is in charge for the denominator. The negative flips the exponential. It's not important anymore. Now it's super, super insignificant. So which situation is that that's going on? They're the same, so we would use 4 and -7. That's really tricky. If you were like, hey, that's tricky, you're correct. 100%. That's tricky. Okay, so you got to be paying attention. So these first few are actually just a review of your unit circle. Remember that the first thing you always do to try a limit is plug in the number. So you would just try to plug in 3 for x, and you would get sine of pi over 3. So this is from, what was our second day of class? We reviewed our unit circle. What quadrant is pi over 3 in? First quadrant. What goes across from that? Good. And so the other side is a half. That's your work. Then you answer the question, which one is sine? The y value. Good. So that would be square root of 3 over 2. So it's really more a trig question than a calculus question, just has like limit put in front of it, but you're just gonna plug in the number. This one says limit as x goes to 4 from the right, still just try 4, like just plug in 4 and see what happens. That's gonna give you cosine 4 pi over 3. So which quadrant is 4 pi over 3 in? Third, yeah, good. And so it's actually the exact same triangle we drew here, just reflected into the third quadrant. Your reference angle is pi over 3. Across from that is square root of 3 over 2. The other side's a half. But good, they are actually both negative. Sorry, that's a negative sign. It kind of ran into my fraction bar. And which one is cosine? Yeah, x, so it would be negative 1/2. And then last one of those, you're just plugging in 5 pi over 6 for x. So it's secant of 5 pi over 6. And we're just going to evaluate that. This is really just review of unit circle, which I love. I love the unit circle. You all do too. Yeah. All right. Where's 5 pi over 6? All right. Second quadrant. Your angle is pi over 6. So across from that, a half, down here, square root of 3 over 2. But it's negative. So secant means you're going to flip cosine, which is x. So you're going to flip this over. It would be negative 2 over square root of 3, which is going to rationalize negative 2 square root of 3 over 3. So again, that was kind of your little quick review of the units. 16 and 17 aren't really problems that we're going to do. These are both properties that you kind of just need to memorize. And you all started the AP Classroom thing. This one's going to like remind you of one of the problems that was on there. And I was like, you can't do that on that. Limit as x goes to 0 for sine of x over x is 1. It's just true. And it's like a property that you need to know. Okay. You can also flip that. So if it was x over sine of x, that would also be 1. Together there. Okay. This one, limit x goes to 0, 1 minus cosine x over x, that goes to 0. And so again, those aren't like problems we were doing. You're going to use those properties to answer some of the rest of these questions. So when you look at number 18, let me zoom in. I usually just circle it. Do you see the sine of x over x part? It's not really a circle so much as like a lima bean, but do you see that part? That part's going to be 1. And so, well, the 3 is in the denominator though, so 1/3 is your answer. Yes. So you need to know the property and you need to be able to identify it in there. Now for number 19, okay. Probably shouldn't put this on the recording. The answer is going to be 5/7. But I want to go through mathematically why that's true, because it's not because of what you're thinking. You need to make these numbers match. So if this is sine of 5x, the denominator needs to be a 5x. It's not, it's a 7. So we're going to multiply the numerator and the denominator by 5, and it's going to look like this. I know some of you aren't writing it down because you're like, I know the answer is 5/7. But I want you to understand why, okay? You'll have a 5 out front, 5 sine 5x. And then down here, I'm going to write the 7 kind of separated, and then we'll have a 5x. So this is the part that's the property, because what's important to understand is the part inside the sine function has to match what's in the denominator. So that part I circled equals 1 times 5/7 is 5/7. So yes, that is your answer, but it's the reason why that works.
So, but like, if we looked at that.
And it was multiple choice, please just select 5/7 and move on, because the exam is timed.
Even if it's here, if it's another number, if it's like 1 or 2 or 3, it's still gonna be 5/7.
Well, no, it would be whatever those numbers are.
No, the limit, the x to 0. Would it change?
Yeah, so like if this was, like if those numbers were different, it would just be whatever those numbers are.
She's asking the limit approaching 0.
Oh, good question. Sorry. Thank you. Yes, the property says it has to be limit as x goes to 0. Thank you. I didn't hit that hard enough, obviously. If it says limit as x goes to 12, that's not the property. Do you get what I'm saying? Like that number has to be 0 for both of these. Okay.
Not one, just.
Yeah, like it has to be 0. Sorry, I didn't understand the question. That was a really good question too. All right, so for this one, what can we do with the numerator? Since they both have a 4, factor out a 4. I heard you whisper it over here. If you factor out a 4, you're going to be left with 1 minus cosine x and then over 9x. So this is the part that's the property. What does that part that I circled equal? 0. And 0 times 4/9 is 0. These last 3 are a little bit tricky. I'm going to end up drawing pictures for them. If you stick with me, I think I can get them done though. All right. We're going to approach pi over 2. If you do cosine of pi over 2, where is pi over 2 on your unit circle? It's at the top. And cosine is which part of that? X value, which is 0. So if you plug in pi over 2, you end up with 4 over 0. Do you remember what it means if there's a value over 0?
It's the analytic thing.
It was in the analytic section that we did. It means there's an asymptote. So you're going to test from the direction you're going and see if it's positive or negative. 4 is a positive number. I don't need to check that. I'm going to draw a cosine so that you can see this visually. Where does cosine start? I know it's a wave, but where does it start? Starts at 1 and it's going to wave like this. So if you're, just watch me point to this because you'll understand it visually. Here's pi over 2. If you're approaching from the left, that's on this side. Coming with me there? Is that part of the graph above sea level or below sea level? It's above, which means that's positive. And a positive over a positive is positive, so it's positive infinity. Yeah, 22 and 23. I got you. It's confusing, so I'm going to do another one. If you plug in pi, where is pi on your unit circle? To the left. Sine is the y. I'm drawing the circles to show you. If you don't need that part, if you can do it mentally, you don't have to draw that. Sine is the y value, that's 0. So this goes to -2 over 0. Again, that means asymptote. -2 is a negative number. We're going to check pi for sine from the right. Sine starts at 0. It's going to do that. Here's pi, and just watch me point to it. If we approach from the right, is that part of the graph above sea level or below sea level? It's below, which means negative. And why is it positive infinity though? Your negatives cancel. So for this last one, you're trying to plug in 0. Here's on your unit circle, 0 pi is right here. Tangent is y over x. So 0 over 1 would just be 0. So what you end up with is ln of 0, which is not a thing because there is an asymptote there. So let's look at our graph for ln. It's going to have an asymptote on 0 and do something like this. As you approach that asymptote, the graph is going down, and so your answer is negative infinity.